Got it.
And let these folks get in and then we'll start. Oh, we got a couple minutes.
Did Kim come on or no?
Kim is not on yet. Is she coming?
I don't know. I assume she was because I noticed that on the other call, and I mentioned to this group that she may come on.
Yeah, that was something else that happened yesterday. She came on and they weren't
Oh,
ready,
okay.
and she may be shying away.
Oh, okay.
I believe this is going to be one of our highest attended presentations by the looks of things right now. We're already at 27.
Well, that goes against what I said. I said the first one had a high attendance, but the rest of them
The first one, yeah.
did not. The rest of them were in the 20s.
Well, the first one had a high attendance, but it was a lot of people who were just checking in to see what the heck was going on.
That's because Jerry is very popular.
Well, that's why we wanted Jerry on this team.
I followed Yen's suggestion and sent out an invitation to a number of colleagues, and I see some of them have joined us today, so appreciate seeing them.
Thank you for doing that.
I was joking, but I was dead. Now I'm just dead serious. Just very popular.
Okay, people are still joining, so I'm going to just wait another minute or so. Andre will be on top of the wait
So
room.
Yan, you are going to do the slide thing, right?
Yes.
Okay,
Okay.
not this person. This person cannot come in. So we remove him.
I see. Thank you.
Will you remove him?
Yeah, I sure will.
Oh,
Cool.
Let's see if
Hello.
Alexa's on here. Hello.
Hi.
And we still have folks coming in, so we will start shortly. So Jerry, whatever you did, it worked.
Well, I'm sure it's the team all together.
All right, folks, I am going to hit record. Is the Chem 2 team ready? Okay, I will introduce and then turn it over to Michelle. Oh, well, we are recording. Okay. So, hi, everybody. Welcome to our 7th webinar this week, demonstrating the digital course collections. We have 10 course collections ultimately going up, and they will all be accessible through the same portal, which we will put up in the chat later today. Thank you for attending, and without further ado, I will turn it over to our fantastic Chemistry 2 faculty team and instructional designers and librarian. And let's see, Michelle, you can take it away.
All right. Thank you, Michelle. Welcome, everybody, and thanks for joining us Today, we will provide a quick overview of the materials and the development process for the materials that we put together to support the second semester of the general chemistry course. We will also provide a quick tutorial on how to navigate our website to incorporate the materials to enhance your own course. So my name is also Michelle Hu. I'm a chemistry lecturer from the University of North Carolina at Greensboro. The other Michelle, she always refers this whole project as the amazing race, and our team is actually the amazing team. We have faculties who teach general chemistry across the system, experts on open educational resources, and experts in educational design. So I would like the amazing team to give you an introduction before we talk about the materials. And I'm gonna give the stage to Dr. Cecile.
Hi, I'm Jennifer Cecil. I'm an associate faculty member in the Department of Chemistry and Fermentation Sciences at Appalachian State University.
Hi, I'm Eli Havascos. I'm associate professor of chemistry at East Carolina University.
Hi, I'm Meredith Storms. I'm an associate professor of chemistry at the University of North Carolina at Pembroke.
Hello, I'm Jerry Walsh, professor of chemistry at UNC Greensboro.
Hi, my name is Yan Xian. I'm an instructional designer from North Carolina State University.
Hi, my name is Jakia Salam. I'm an instructional designer and I'm also from North Carolina State University.
Hey, I'm Will Cross. I'm the director of the Copyright and Digital Scholarship Center, which means I'm a lawyer and a librarian, and I'm also at North Carolina State University.
I'm Andre Richardson. I am the UNC System Office liaison for this project.
All right, thank you, the amazing team. So in response to the COVID-19, the UNC system has several projects designed to enhance the instruction for remote learning situations. And this project targets some high population courses, and general chemistry is one of them. So our team focuses on the second semester of the general chemistry class. We used open educational resources so that our collection is very flexible and adaptive to instructors and students across the system. You can choose to use the entire collection that we put together or part of it. The materials will support both online and face-to-face classes. It includes OER textbooks, lecture videos, study guides, demos, assessment questions, and so on. And what's really cool is we even have virtual labs and simulations for some modules that you can use during your class or let the students explore. So this collection focuses on core student learning objectives that are most commonly used across the state or even across the country. So you will hear more about that in a little while. We also incorporated STEM-related and chemistry-specific diversity, equity, and inclusion into the relevant modules of this collection. Next slide. So our intended users are instructors who teach general chemistry 2 or related courses with or without experience. But like I said in the beginning, the collection is very flexible and adaptive. So we have a wide range of potential users. Other courses that could benefit from this collection includes high school AP chemistry courses, general education science courses from non-STEM majors, GOB courses taken by nursing students, and even some higher level chemistry courses like organic, biochemistry, and quantitative analysis. So you will always find something useful here and there. So next, we're going to talk about the OER resources that we used most and why we use them.
Thanks. So something I bet not many people expected when they began this project was a crash course in copyright and licensing, right? That probably wasn't at the top of everybody's agenda. But the issue of how we can use, reuse, remix, and reliably point to resources became pretty important pretty quickly. And so for those reasons and some reasons that a couple of other folks are going to talk about in a minute, we began, as Michelle said, with a foundation of openly licensed resources, what are often called OER, Open Educational Resources. And as Michelle said, these are textbooks, videos, worksheets, and more that are free for the system, they're free for faculty, and they're free for students to use. But because they have an open license, they're not just free, but they're also reliable and editable. So they can be customized as we develop the initial resources, and so that individual downstream users can tailor and localize to the various teaching styles and the diverse campus context that we hope will use this resource. As you'll see, we also included a smattering of resources that are free on the web but not openly licensed. So the final product is a mix of those two, and we've done our best to clearly label each of those. So to hear more about how we selected specific resources, I'm going to turn it over to Jackie.
Thanks, Will. So once we decided on open educational resources, we first step was to create a list. Just go to the World Wide Web and see what's out there. And there are so many materials could be found there. It's really overwhelming. So what we did, we started to create an initial list. You can see in the screenshot over here, and kind of categorize the resources like OER textbooks, materials, OER videos, general websites, simulations. We also added some lab resources. So this is a big list we kind of put together. And it was kind of overwhelming to actually put this together because there is so many things out there. So the challenge is what to take and what to discard. So what, as an instructional designer, I did couple of things. I took a couple of things that like Marlowe has a good resource, OpenStax, and OER library has good resources. And also our faculty team experts over here, they provided us information, what they use for their courses. So once this list was put together, we handed over to our faculty team experts over there. So I'm going to pass it to Meredith now. So she's going to talk about how the faculty actually selected and used this material in this course.
Thank you. As has already been mentioned, there are a lot of resources that can be used in a variety of ways, but the open educational resources have the advantage in that they are free to the students. And that means they are free before the class even begins, and also after the class ends, they do not have to return the textbook back to the bookstore or sell it to someone else. They still have ongoing access, which is an advantage because as they progress through chemistry, they can still refer back to these types of free resources. The other thing in terms of faculty, as has been mentioned, is that these materials can be edited in order to fit the learning objectives that individual faculty have for their own courses. So the OpenStax book was selected. We felt like it gave a comprehensive overview of every topic that we had chosen in terms of the learning objectives. And also we somewhat chose it because it highlights one of our UNC faculty members. Dr. Flowers is a senior author on that book. Some of the instructional materials from UC Berkeley, UC Irvine are very comprehensive. Some of us do like those because they have a lot of lecture notes that coincide with the lecture material, but some of those lectures do tend to be somewhat lengthy, and so we had some discussion about how to divide up that material in order to make it more adaptable to students to listen, 15, 20 minutes at a time. The Khan Academy videos are a little bit shorter in length. Some of those do provide worked example problems, which in chemistry is important, so we tended to use those quite a bit. And then also the PhET interactive simulations, we chose some of those. Some of those are incorporated into the modules, as demonstrations for the lecture. Some of those are incorporated as potential virtual labs. So again, because they are OER, there are a lot of opportunities to be flexible and edit and revise those materials to best suit the individual faculty needs. So I will pass it on to Yan to talk about the project process.
Thank you, Meredith. Okay, so this project has a short timeline of 5 weeks, but we were still able to go through the classic course design process of analysis, design, and development. So we didn't jump directly into developing modules, but went through a systematic process that allowed us to develop a set of modules with consistent structures and well-aligned materials. So during the analysis phase, the instructors kind of collected the student learning outcomes, topics, subtopics from different institutions, and then synthesized them into our student learning outcomes and topics. So as you can see, our instructors did a lot of work at the beginning, from the very beginning of the project, mapping out every single element of the Chem 2 course from their institution. And Jerry from UNCG even looked at Chem 2 from other UNC schools. Jerry?
Yeah, we certainly appreciate and thank the other schools for responding rapidly and in terms of providing information about their General Chemistry 2 course. In the middle of the screen, you can see a number of them that we had contacted, all indicated by appropriate color code there, according to the school colors. So Winston-Salem State, Western Carolina, Fayetteville State, and so forth. So we looked across the topics that were common for General Chemistry 2, and if you look in the middle of the screen, many of them were really standard across all different disciplines. There were a couple of areas that were kind of on the fringe. For example, gases might have shifted between Gen Chem 1 and Gen Chem 2, and it was decided within this program that the Chemistry 2 would be the location for gases. Nuclear chemistry and radioactivity was also something that wasn't regularly common, but we did include that in the General Chemistry 2 as well. So the topics that were chosen tried to be comprehensive across the various schools in the UNC system.
Thank you. So those topics that we synthesized became the basis of our modules. So moving on to and those modules were assigned to instructors on this team. And then moving on to the design phase, we set up the curriculum map where the instructors worked on designing the modules that they are assigned with. And then again, they did a lot of work breaking down each module into subtopics and then identify the detailed learning objectives of each subtopic. And then they collected and organized instructional materials, activities, and assessments from those various OER resources, and then align them back to the learning objectives. So here is an example of a module design table from our curriculum map. So every module is aligned back to the student learning outcomes of the course. And then the table has, like, they focus on 3 columns: the learning objectives, instructional materials, activities, and assessments. And then each row is a subtopic. Eventually, each subtopic became a module page. We numbered all the subtopics and learning objectives and really made sure all the different types of resources are aligned back to the learning objectives. And then before moving on to the development phase, the instructors did an internal peer review of the modules that they didn't work on using a set of criteria. So given the short timeline, they mainly looked at, like, the alignment of the learning objectives, making sure, like, the materials and activities can help address the learning objectives. And they also look at the quality of the module elements and collecting materials, and also checked on the format. And then in the last phase of development, the instructors assembled the materials from the curriculum map into individual subtopic pages. So here's an example of what they did in developing the actual modules. So basically they took the information from the curriculum map and then kind of added more details to it, like descriptions, teaching tip, answer keys, license information. And then they also developed the introduction pages of each module. So now I'm going to pass on to Jerry again to talk about student learning outcomes.
Okay, thank you, Ian. Yeah, the instructional designers on our team were very good about laying out the path for designing the course. They laid out the framework and also led us stepwise through the various steps. And in terms of appropriate instructional design, we began with the student learning outcomes for the course as a whole. So we ended up with 8 student learning outcomes as indicated on this particular slide. You can see that many of the student learning outcomes tend to be tied to the topics that are typical for General Chemistry 2. I have to say that the team as a whole probably had more discussions about learning outcomes than the other materials that are part of the course that we've put together here. And obviously that's a very important place to start. So again, covers in general the expected topics with, we hope, are clear statements that are useful for faculty, but also interpretable by the students as they're coming new into the particular topics here. You notice some of them are broader in nature in the sense that I think it was number 2 and number 4 really focus on molecules, which are the basis for chemistry. Number 8 was really the sort of a common learning outcome for all of the modules, being applying problem solving and mathematical analysis, since that's really a lot of General Chemistry 2. Then from the student learning outcomes, we went into the module design as shown on the next slide. And this slide shows the faculty developers for each one of the topics, and also indicates the student learning outcomes that we thought most appropriately applied to the various modules in our program. And I guess I got a little bit ahead of myself there in the sense that you notice that some of the student learning outcomes like number 2 and number 4 permeate several of the modules, and number 8 really all of the modules in terms of problem solving and so forth. So that's the instructional design from the point of view of the student learning outcomes that we have generated.
I'm going to talk a little bit about our website design. So everything we created, we want to kind of put it in a front-end web page. So in the beginning, we want to make it a very simple and easy to navigate. So I'm going to start with our homepage. So in our homepage, we have a little bit about the Chemistry 1, the student learning outcome. And we also have our design process, explore module, enhance your course, these pages. The navigation was kept in the top, and we also provided a link over here. So if you're interested, you can see. Next slide. Yeah. The next slide is the process slide where we put the diagram that Jan just talked about. And also we have a little weekly breakdown of tasks we did, put some links to the important document like curriculum map and project timeline. Also, we put a slideshow for our webinars slide, so people, if they're interested, they can view that as well. Next. So this is our actually I'll say the main page where all the resources do exist. So explore modules, you can see the first link, we have the curriculum map because that's the heart and soul of our project. And then we have provided access to the entire Google folder. So if somebody wants to review all the resources, they can just access that Google Drive folder right in there. Then we have module 1, all the modules listed like this. So module 1, when you click on module 1 gases, it will land you to the module intro page. And then we have all the subtopic page. These are all Google docs and a link there. We also provided a little link over here that access to module 1 content, which actually give you access to that particular module drive pages. Next. So enhance your course is something, this is like a, the entire thing we just have is kind of like a blueprint. So you can actually take this, any faculty can take this, copy this, and in their LMS, they can put up a course in a very short time. So what we did, we have in this page, we use, the main thing is to the link to the faculty resource guide for chemistry 2. In that resource guide, all the teaching tips and everything is listed. So trying to keep it simple as possible. The next. And the next page, we got a brief introduction of our team. We specified the faculty team, instructional designers, a librarian, OER copyright issues, UNC system office liaison, so everybody can go to the right person if they need to contact them in the future. Next. This is actually our folder structure in the Google Drives. So we have a root folder, Chemistry 2, and under that folder, we have all the module folders. We also have resources, project management, and support materials, these 3 additional folders. We put curriculum map and the website in the root folder. And if someone clicks say module 1 gas, they will be presented with this folder structure in the right. So they will have all the submodule pages over here. So and there you can see there is another folder called linked files. This is something we gathered a lot of OER materials from the web. There is one thing you have to keep in mind. What if some of these resources vanishes in the future? Like you were using a video and at certain point that video is no longer there, or you are using a worksheet that's no longer there. So we tried to download as much as possible, discussing with Will about copyrights, and put them in this linked file. And from this linked file, everything is linked to these documents. So even it disappears from the web, it will be in there. So we try to keep the structure very simple and efficient as possible. Now I'm going to pass it to Yan. I just talked about, she's going to talk about the structure of the pages.
Thank you, Jackie. So we set up a common structure for the modules and developed templates that were used during development. So we have templates for introduction pages and templates for subtopic pages. So the introduction page really serves as an overview of the entire module and also ties back to the course student learning outcomes. And then the subtopic pages covers the key components that students need in order to complete online learning successfully. So now next, we are going to walk you through an example of the introduction page and the subtopic pages.
Okay, yeah, this is Jerry again, talking about the introduction page. So every one of the modules has an overview page as an introduction. And you notice on the left-hand side, table of contents up front with links to each one of the subtopics within the module. The overview, those of you who are experts at teaching general chemistry will have a very good idea of what the material would be in that particular course. But this can be used for students as well. So students can get a good idea of what the material will be in a particular module. We list also the keywords at the bottom there. So a resource for the students in terms of keywords to be aware of as they're studying the particular module. And of course, we link it all to the student learning outcomes for the course. So we hope a very valuable feature of the introductory page, and actually the module pages have some of this as well, will be teaching tips. So the teaching tips give a good idea in terms of the structure of the module. It can review what the students should know as a foundation for going into the various modules that are here, and give some guidance to the instructors for how they can incorporate the various instructional materials there, from the lectures to the videos to the conceptual ideas that can be presented. We hope that this is a good overview and useful tool for being able to use the various modules in your particular course. The item at the end there, diversity, equity, and inclusion. Obviously, in today's society, this is something that's critically important, and we should work harder as scientists for the incorporation of this into the society of science, and what society or what chemistry contributes to the world around us. I know UNCG, I can be very proud of them, and I'm sure a lot of the other institutions were this way as well, and we're addressing this issue before it really took the forefront in the past couple of months here. You know, our dean and chancellor had taken major initiatives, and our department is following up on that. So I'm sure all of you are as well. So including this in your courses as you go forward, we really encourage that. So Meredith is the designer of this module 3, and she incorporates a couple of really nice diversity issues here related to chemistry. So probably everyone has heard of the Flint, Michigan water situation, and the environmental racism that's associated with that particular topic. The next one is a list of 9 Black chemists that you should know. So here's a nice little article on, let's see, this is Betty Washington Green, who was the first Black professional at Dow Chemical. Really encourage you to make use of the DEI components of the course here. Okay.
All right, so this is Eli Havascos. I'm gonna talk us through the first part of Dr. Storms's module here. So most of the modules, not all of them, or all the subtopic sites start with a background type of information, where it might be just a general topic that kind of links the student into the more, chemistry related topic later on. And so Dr. Storms here selected this Bangladesh arsenic project by Chemists Without Borders. And it's a very, these are the cool parts of these modules, where we get to go look at the everyday applicability of this. So this is a project where these folks went and measured arsenic concentration in these wells in Bangladesh. And if you click on these maps, or these little map markers, it comes up with the concentration of arsenic in the well, and it comes up in parts per billion, which is one of the units that we are going to talk about in this particular subtopic module if we go back. So what that would do is be a good start for the professor to kind of introduce this topic and talk about how concentration units are very important in this, everyday kind of sense. And then kind of goes back to the module, right? So the subtopic page. And so that gets us to the learning objectives, right? So this is concentration units subtopic page. So the learning objectives here are going to be concentrations in terms of molarity, mass percentage, molality, stuff like that. And parts per billion and million are in there. And so you can see how we've linked the learning objectives in the background there to one of the more specific learning objectives of the subtopic page. So those are all listed in all of the other subtopic pages as well. And then, so once that's all kind of introduced, we've got prior knowledge review for the students to go back into maybe a previous module from Chem 1, or maybe even in Chem 2 as well. But here we've selected, molarity gets introduced in Chem 1, So Dr. Storms has found the module in Chem 1 and linked back to it. And so brings the student to kind of, hey, review molarity here so you can, you know, get up to speed with, we're gonna expand on those ideas and give you more concentration units to talk about, to develop. And then, so that's all the prior knowledge review. We go over to the instructional materials, all the modules, then list the instructional materials. Most of us listed the textbook sections in the OpenStax book, the Adams First. And so Dr. Storms here is linked back to, you know, first semester chemistry for molarity and some other units, and then the chapter 11 for the colligative properties examples. And so some other professors have links to, you know, other books that with sections that might be relevant. Just depends on the particular subtopic. Once again, linking back to the specific learning objectives at every step along the way. And then the final part here is we went out and found the video resources we liked to, that we thought were the best to kind of reiterate this information, to support it. And so the videos here, we've got molarity, molality, and mass percent calculations, parts per million, parts per billion calculations, and mole fraction calculations. You can see that the license and where it comes from. Here we've got the organic chemistry tutor, or the pharmaceutical calculations that she has selected as kind of reiterating these particular learning outcomes. So if you click on these, some of them are going to be shorter, some of them are going to be longer, but they're going to go and support those learning outcomes. So if we've collected here, this takes you right to the YouTube link, and, you know, we present the student the information to kind of, after we get past that ad, but it would, you know, give the information the students need to, you know, to reinforce that learning outcome. A lot of, you know, these videos all depend on what the professor kind of liked in there. So they're not all going to be from the same source. I know I personally kind of utilized maybe a little more Khan Academy and some other people for mine. So it just kind of depended on what was, you know, what we felt was more quality. But they all kind of reinforce those learning outcomes or learning objectives there. And that's my point. So I now toss it over to Dr. Cecile to talk about the assessment part of the module.
Thank you, Eli. So if you take a look at the activities and assessment page for each submodule, you'll see that they're broken down into conceptual activities and assessments and application activities and assessments. And I just want to briefly tell you how we segregated these topics. So if you're looking at the conceptual activities, these are the activities we think students could do on their own. The first one that you might see would be a study guide. And Yan, if you'll click on that, it suggests that this study guide is about molality and molarity. So these are OER resources that are completely customizable, but this at least gives instructors a template to use. These were originally designed for a flipped classroom exercise, but they're great for students watching some of these lecture videos or even your own lecture videos and taking notes, being exposed to some of the preliminary types of calculations that you might see in one of these subtopics. So these are fantastic resources that you can point students to do on their own that are not for grade. So Yan, if you'll click back to where we have other conceptual and activities. So you'll notice that each of the concept activities and application activities, they all have the teaching tip underneath them, how we think you might best utilize these resources in your classroom. So if we look at the study guide, it suggests that it could be used in a flipped classroom, but we think that you might be able to use it for students watching a video or reading the text on their own. Where we were able to find answer keys, we've also included those for you such that you may share them with students as you like, or you may utilize them for yourself. And moving on, then you'll see some other activities that are linked under our application activities. So these might be textbook exercises or worksheets. And we typically consider these exercises where after the students had a better understanding of the material, after they've already done the study guides and gone through most of the material. So Yan, if you'll click on one of our textbook exercises, we'll look at exercise 22 from the OpenStax book. And it'll ask different questions. I think you have to go down the slide, Yan, because we're at number 1. So if we go to one of the problems suggested, like 22, we could have the students calculate molarity for each of the following solutions. And most of these have resources as far as answer keys associated with them as well. These would be the types of calculations that you would assign for homework. Or I wanted to share just briefly what I ended up doing in my summer 1 class, which was completely online. So in my summer 1 class that was asynchronous, I had students listen to videotaped recordings of my lectures, and I met them twice a week for what I called problem-solving sessions. And at the end of the course, I did a survey among my approximately 40 students, and 90% of them suggested that even if they were in a face-to-face class, they would prefer that type of design to their lecture, that they found the problem-solving sessions very helpful, and they thought that they could handle the lecture material that was pre-recorded for them on their own in a way that made it more useful to them to get the problem-solving skills out done in class so that they could clear up any confusion and work through these types of calculations. And if you think back to what our learning outcomes actually were, you saw that most of our modules had the problem-solving strategies built into them. So this type of design where you might have lectures posted online, and when you're able to spend face-to-face time with students working through problems like this, I think would be a great way to utilize these resources in our upcoming semester. The other thing that I really like about the design of these modules is it gives a description of the problem. So if students tell you that they're having problems with calculating molarities and molalities, you could go to one of these submodule pages and pick out specific exercises to address that concern. And I would encourage you to use whatever teaching technologies that your systems might have, like a VoiceThread or discussion board or Flipgrid, in order to get student participation and picking out what problems they might want to see. So those are just some of the ideas that we had. You'll see variations of these through all of our different submodule pages, and putting them into place in your current textbook and your current semester's topics should be a very easy process. So with that, I'll turn it over to Yan so she can actually tell you more about how we think that might work.
Thank you, Jennifer. So really, as you have seen, like our modules are really designed with students in mind. So we hope that the subtopic pages can be used almost entirely in a course, in a Chem 2 course with minimal adaptations by the instructor. So to adopt the Chem 2 resources that we have developed, you can adopt like an entire page or adopt individual resources. So if you are adopting an entire page, all you need to do is you can open the subtopic document, go to File and make a copy, and you have that copy in your own Google Drive, and you can drop the link in your course LMS. Or if you want to use a set of pages, you can go to our module folder, which is already in the Google, in our Chem 2 website. You can select a set of pages and then right-click to make a copy of all of them. Please remember to remove the teaching tips and answer keys before sharing with your students. And then if you're adopting individual resources, you're more than welcome to take out like the most relevant resources for your course. And you can add the resources, the links or files, and then also include the license information. So that's we would like to share about the Chem 2 resources that we have developed, and we are happy to take on any questions that you have.
Thanks, Chem 2 team. That was fantastic. Karen Singer-Freeman just posted a link to a survey. So while you're thinking of questions, please, if you would be so kind, fill out our survey. That will help us a lot moving forward. So questions for the Chem 2 team. We see lots of nice comments. Great job, excellent work. Lots of things.
This is Jerry. Maybe I'll add a comment here. Just to follow up on our textbook selection, I thought that it was very good. I have not used an open textbook previously, but I thought this OpenStax chemistry, Adams First, was quite good. And just to mention that associated with that, there is an instructor resource page with that, which will give answers to all of the homework questions at the end of the chapter. There's also a student resource guide as well, which gives answers to, I believe it's the even numbered questions. So I was impressed by that particular textbook.
See, thanks, Jerry. There is a question from Carmen Huffman, and it's how is this team approaching the fact that students may find the answers to some of the things that are up there, the answer keys? How did you all approach that?
That's a good question. We did have some conversation within the team. I think both Chem 1 and Chem 2 team talked about this. So right now, I think technically we don't have a way to hide answer keys from the students. The way we set up the documents is the documents themselves are not searchable on the internet because I think the documents themselves, the pages are not published to the internet. So only people with the link can view them. So if you are making a copy of those documents, please, and if you want to share with the students, please take out the answer keys before you share. And then, yeah, I think the best way is probably just to avoid sharing those pages directly with students, but make a copy of it.
The calculus team had a really good answer for that question, and that's that they suggested that you use those answer keys and those questions for students to practice, but that you change them for if it's a final exam or something like that.
Yeah, I think that's also a good idea. So it's not exactly the same.
And the textbook we're using, it actually has a whole collection of the test bank, and only the instructors can have access to all the keys. So you can pull more questions from there if you don't want to. You don't want the students to see the answers.
We have another question. How useful did the team find those PHET simulations?
Well, I think it depends because I put one of the PHET lab resource in kinetic molecular theory. And I think it's very useful because students cannot see gas particles. And with the virtual lab, they can actually play with it, increasing the temperature, increasing the pressure. So it will help them to have a better understanding of what they cannot see in real life. But for some other sub-modules like concentrations, I'm not sure because it looks like students can actually do them in a real lab. So probably Dr. Storms have some comments on that.
I agree. Some of them, I think if you go onto the website where they have the list of where different people have contributed, I guess, the instructions and how they're using it, I think you have to sort of filter through and find the ones that you think are relevant to you. For the ones that I use, that's kind of what I did. I just tried to find the ones that connected back more specifically to the topics covered in the module. But I do think it gives the students a chance to play around with some things and, you know, try to question a little bit better things that they cannot question if they're in an actual lab because of the safety, but you can do that virtually. So I think some of them are very useful. Some of them seem a little more complicated and like they might need a little more instruction if you are going to give those to the students. So I think you have to just look through them and find the ones that you think are most suitable for your student and the topic that you're covering.
I agree. I used them for kinetics. The only problem I had was mine required a download or something like that onto my computer. So that was a little bit weird, and I was worried that students couldn't figure that out, but maybe that was just because I'm getting old. But I thought they were pretty useful as well.
So we have a couple of other questions. When will updates be made to the courses, and is a similar project be considered for virtual chemistry lab resources? So I'm wondering if this team could maybe address the any lab exercises that are included in this collection.
Well,
Right.
we didn't develop a real lab for this collection specifically, because normally the lab is a different course than the lecture. But we did try to incorporate as much lab resources as possible in our collection. And also we had discussions all the time about what kind of virtual lab softwares or website we can use to help with lab classes.
Yes, we did not do anything like in lab, but in the resource list, we did provide some lab resources like Labster, LabFlow, whatever virtual lab we found over the web. So it could be helpful for the faculty in the future if they're looking for a course that specifically targets lab design, because that would be more challenging as well.
And when will updates be made to these collections?
Well, just to comment on that, at least I feel that what we have posted at this stage was something that was prepared fairly quickly. And we'll continue to improve them, make corrections and improvements. So that will be an ongoing process. And I certainly welcome suggestions. If you have something that you have used that you found is really outstanding and wonderful, feel free to share it with the particular content faculty person that would be appropriate for that, and we'll consider it for inclusion.
Yeah, we have those information like the primary author of each module on the Chem2 website. So if you see wonderful resources that can be included in these modules, please reach out to the instructor who worked on that.
I believe the slides are available off of the Google site table of contents page. I heard you say that, right?
Yes, it is. It is available off the Google, of the website.
I hope this team is monitoring the chat. There are some fantastic thank yous and kudos coming through. And we at the system office, thank you very much for everything you've done. This is an incredible collection. And I'm sure it's going to be well used in the coming months. Any reason to put the gas laws content? Oh, I can't answer this. Any reasoning to put the gas laws content here rather than in Chem 1? Also, how deep is the nuclear part?
Maybe I can answer on the gas part. So normally the gas chapter is part of Chem 1, but the thing is oftentimes faculty members, they didn't have time to finish that chapter until the start of Chem 2. So since this is a chapter kind of in between, so we had some discussion with Chem 1 team. You can also ask them later on, but we just kept them here in Chem 2, but content-wise, there should be no difference.
Yeah, and the structure-wise, both Chem 1 and Chem 2 has very similar structures. So content, like you probably won't feel too much differences going from one collection to the other.
There are some overlapping issues.
Yeah, the structure is very consistent.
So I will add to that, that the same instructional design team that put this course collection together also put Chem 1 together. So the it's more than similar alignment, and we encourage you to adopt a small part or the entire thing, whatever fits for your existing course and the existing student learning outcomes that you've defined for your department. And I agree, this is an excellent set of resources. All
There
right.
was a question about the depth of the nuclear part.
Oh, the depth. Yes,
Just to
sorry.
comment on that quickly. I think we cover the basic topics under nuclear chemistry. It's radioactive decay, half-life, let's see, fission, fusion, and do get into some of the applications of nuclear energy in the energy industry, and also a fair number of topics related to the application of nuclear chemistry in medicine. So we hope that'll be reasonably effective and comprehensive there.
Are there any other questions?
There was also a comment about signing in at 4 p.m. for the Chem 1 webinar as well. Someone put that in the comments. I'm in the chat.
Yeah, we encourage all of you to come to the Chem 1 webinar as well. Although the structure is similar, but we have a variety of like topics that's appropriate for Chem 1, so you will get a sense of what's available there.
Mm-hmm.
And don't forget to give us feedback on our survey. And Jim Pazinski, who is our Vice President for Digital Learning, says fantastic work. Lots of hard work represented here. Many thanks. It will be so beneficial to support our growing use of online. Thank you, Jim, for attending. And supporting. Make a plug that Jim has a faculty development series going on now. So if anyone wants more instruction on online, how to teach online, Jim's done a fantastic job pulling that together. And this video is recorded, and I am getting ready to end that recording. Thank you so much, everybody. Oh, I forgot to do the clapping, which I do for everybody.
Well, thank you all for coming.